Here are 10 USMLE-style questions based on de novo pyrimidine and purine synthesis, nucleotide synthesis inhibitors, and related pathways. Each question comes with 5 multiple-choice options, explanations, and why the other options are incorrect. Header 1. Which of the following is involved in the de novo synthesis of pyrimidine bases? A. Aspartate, B. Glycine, C. Glutamine, PRPPE, CO2. Answer: A. Aspartate, glutamine, E. CO2. Pyrimidine-based synthesis requires aspartate, glutamine, and CO2. PRPP is involved in purine synthesis, and glycine is more relevant to purine biosynthesis. Which enzyme is inhibited by leflunomide in the pyrimidine synthesis pathway? A. Dihydroorotate dehydrogenase. B. Thymidylate synthase. C. Carbamoyl phosphate synthetase 2, CPS2. D. Ribonucleotide reductase. E. Inosine monophosphate dehydrogenase. Answer: Dihydroorotate dehydrogenase. Explanation: Leflunomide inhibits dihydroorotate dehydrogenase, which is a key enzyme in pyrimidine synthesis. The other options are involved in different steps of nucleotide metabolism or purine synthesis. 3. Which of the following drugs inhibits thymidylate synthase? A. Methotrexate, MTX. B. 5-fluorouracil, 5-FU-C azathioprine, dehydroxyurea, E. Mycophenolate. Answer: B. 5-fluorouracil. Explanation: 5-5-FU inhibits thymidylate synthase by forming 5-FDUMP, blocking the synthesis of DTMP. Methotrexate inhibits dihydrofolate reductase, not thymidylate synthase, and the other options affect purine synthesis or ribonucleotide reductase. 4. Which of the following drugs inhibits purine synthesis by inhibiting the enzyme PRPP synthetase? A. 6-mercaptopurine, 6-MP, B. Methotrexate, C. Azathioprine, D. Hydroxyurea, E. Mycophenolate. Answer: A. 6-mercaptopurine, 6-M. Explanation: 6-MP and its prodrug azathioprine inhibit PRPP synthetase, which is involved in purine synthesis. Methotrexate affects folate metabolism, and hydroxyurea inhibits ribonucleotide reductase. 5. Which of the following is the mechanism of action of methotrexate, MTX? A. Inhibition of dihydroorotate dehydrogenase. B. Inhibition of ribonucleotide reductase. C. Inhibition of dihydrofolate reductase. D. Inhibition of inosine monophosphate dehydrogenase E. Inhibition of thymidylate synthase. Answer: C. Inhibition of dihydrofolate reductase. Explanation: Methotrexate inhibits dihydrofolate reductase, leading to a decrease in DTMP and impairing DNA synthesis. The other options represent the mechanisms of other drugs like leflunomide, hydroxyurea, and mycophenolate. 6. Which of the following is the effect of mycophenolate in purine synthesis? A. Inhibition of dihydroorotate dehydrogenase B. Inhibition of ribonucleotide reductase. C. Inhibition of inosine monophosphate dehydrogenase. D. Inhibition of PRPP synthetase. E. Inhibition of thymidylate synthase. Answer: C. Inhibition of inosine monophosphate dehydrogenase. Mycophenolate inhibits inosine monophosphate dehydrogenase, blocking the conversion of IMP to GMP in purine synthesis. The other enzymes listed are involved in different pathways of nucleotide metabolism. 7. Which of the following drugs inhibits ribonucleotide reductase? A. 6-mercaptopurine, 6-MP, B. Hydroxyurea, C. Azathioprine, D. Leflunomide, E. Methotrexate, B. Hydroxyurea. Explanation: Hydroxyurea inhibits ribonucleotide reductase, which is essential for the conversion of ribonucleotides to deoxyribonucleotides. The other drugs target different aspects of nucleotide synthesis. 8. Which of the following statements about the salvage pathway of purine synthesis is correct? A. It requires de novo purine-based production from glycine and aspartate. B. It produces purine nucleotides from recycled bases. C. It requires ribose 5-phosphate and CO2. D. It is unaffected by drugs like 6-MP and azathioprine. It is the primary pathway for pyrimidine-based synthesis. Answer: B. It produces purine nucleotides from recycled bases. Explanation: The salvage pathway recycles purine bases, like adenine and guanine, to form purine nucleotides, whereas de novo synthesis starts from scratch. The other statements are incorrect as they refer to de novo synthesis or different aspects of metabolism. What is the role of carbamoyl phosphate synthetase 2, CPS2, in nucleotide metabolism? A. It synthesizes ribonucleotides from ribose 5-phosphate. B. It converts carbamoyl phosphate into orotic acid in pyrimidine synthesis. C. It synthesizes purine nucleotides from IMP. It converts inosine monophosphate to adenine and guanine. E. It catalyzes the first step of the urea cycle. Answer: It converts carbamoyl phosphate into orotic acid in pyrimidine synthesis. Explanation: CPS2 is involved in pyrimidine synthesis and catalyzes the formation of carbamoyl phosphate, which is converted into orotic acid. The other enzymes and reactions are involved in purine synthesis or the urea cycle. Number 10. Which of the following drugs is a purine analog that inhibits de novo purine synthesis? A. Hydroxyurea, B. 5-fluorouracil, C. 6-mercaptopurine 6-MP, D. Leflunomide, E. Methotrexate. Answer C. 6-mercaptopurine 6-MP. Explanation: 6-MP2 is a purine analog that inhibits de novo purine synthesis. The other drugs listed have mechanisms of action that affect different aspects of nucleotide metabolism, e.g., thymidylate synthesis, ribonucleotide reductase.